Q5286. If the glider's radius of turn is 175 feet at 40 miles per hour, what would the radius of turn be if the TAS is increased to 80 miles per hour while maintaining a constant angle of bank? A. 350 feet. B. 525 feet. C. 700 feet. The correct answer is C. To determine the radius of turn, we need to consider the centripetal force acting on the glider. Centripetal force is given by the equation F equals m multiply v2 / where F equals centripetal force m equals mass of the glider v equals velocity, TAS, true airspeed, r equals radius of turn. In this case, we can assume that the mass of the glider remains constant, and we are changing the TAS while maintaining a constant angle of bank. When the TAS is increased to 80 miles per hour while maintaining a constant angle of bank, the velocity, v, in the equation increases. To maintain a constant centripetal force and a constant angle of bank, the radius of turn, r, must increase. 5290. With regard to the effects of spoilers and wing flaps, which is true if the glider's pitch attitude is held constant when such devices are being operated. Disregard negative flap angles above neutral position. Retracting flaps? A. Will reduce the glider's stall speed. B. Or extending spoilers will increase the glider's rate of descent. C. Or extending spoilers will decrease the glider's rate of descent. The correct answer is B. When spoilers are extended or flaps are retracted, they increase the drag on the glider's wings. This increased drag will cause the glider to descend at a steeper rate for a given pitch attitude. Essentially, the increased drag acts as a braking force, reducing the glider's lift and causing it to descend more quickly. Therefore, when the pitch attitude is held constant, extending spoilers or retracting flaps will increase the glider's rate of descent. 5291. If the angle of attack is increased beyond the critical angle of attack, the wing will no longer produce sufficient lift to support the weight of the glider. A. Regardless of airspeed or pitch attitude. B. Unless the airspeed is greater than the normal stall speed. C. Unless the pitch attitude is on or below the natural horizon. The correct answer is A. The critical angle of attack is the angle at which the wing stalls, meaning it can no longer generate enough lift to support the weight of the glider. Once the angle of attack exceeds the critical angle of attack, the wing will stall and lose lift, regardless of the airspeed or pitch attitude. Even if the glider has a high airspeed or a nose-down pitch attitude, exceeding the critical angle of attack will still result in a loss of lift. It is important to avoid exceeding the critical angle of attack to maintain sufficient lift and control during flight. 5292. What force causes the glider to turn in flight? A. Vertical component of lift. B. Horizontal component of lift. C. Positive yawing movement of the rudder. The correct answer is B. The force that causes the glider to turn in flight is the horizontal component of lift. When the glider is banked, the lift force is divided into two components. The vertical component, which opposes gravity and supports the weight of the glider, and the horizontal component, which acts perpendicular to the banked wing and provides the centripetal force necessary for turning. By adjusting the bank angle and controlling the distribution of lift, the glider can generate a horizontal component of lift that creates the necessary centripetal force to turn the aircraft. This allows the glider to change its direction without relying on engine power. 5293. Given, glider A wingspan is 51 feet, average wing chord is 4 feet, glider B wingspan is 48 feet, average wing chord 3.5 feet. Determine the correct aspect ratio and its effect on performance at low speeds. A. Glider A has an aspect ratio of 13:7 and will generate less lift with greater drag than glider B. B. Glider B has an aspect ratio of 13.7 and will generate greater lift with less drag than glider A. C. Glider B has an aspect ratio of 12.7 and will generate less lift with greater drag than Glider A. The correct answer is B. Aspect ratio is a measure of the efficiency of a wing and is calculated by dividing the wingspan by the average wing chord. In this case, Glider B has a higher aspect ratio, 13.7, compared to Glider A, 12.75. Higher aspect ratio wings tend to generate greater lift with less drag, particularly at low speeds. Glider B's higher aspect ratio means that it has longer and narrower wings compared to Glider A. This allows Glider B to generate more lift for a given wing area, resulting in improved performance at low speeds. It can maintain a higher lift-to-drag ratio, allowing for longer glides and better overall efficiency. Therefore, Glider B with its higher aspect ratio will generate greater lift with less drag than Glider A at low speeds.